Okay, we're ready to go? Yeah, I got the sign from Mr. Bunger, so we launched these. Welcome, everybody. A lot of gentlemen and one lady, special welcome to you. My name is Roberto Söderhäll, and if you're not a Swede, don't try to pronunciate that. You may hurt yourself. We're going to launch 1 year work together in the community from the data center facility group with a project for a modular data center optimized for OCP hardware. It's the first of a kind, and later on Neal from Schneider Electric will present a standalone unit ready to deploy OCP hardware. But first of all, I will give you a historical review about the process that we have been working with, and this is also a generic way of working within the OCP community. So if you're new to this concept, this could be of interest for you. I try to keep up the pace here because Scott is hitting a flight. Yeah, no, we will manage. The OCP project process is interesting. A year ago, we launched this project here in San Jose. It started up, phone up Rob Bunger, who was the project lead at the time for data center facility, say, hey, I got an idea. Why don't we develop a modular data center optimized for OCP hardware? Interesting thing, he said, please send in a mail with your outlining your ideas to the community, and we create a project charter. So we did, and Brevin, I think you called me up and say, be in the monthly call, and we take it from there. And we started with a draft project charter that was accepted, and we launched this project a year ago here in San Jose. It started with an idea. So if you have an idea, please share your idea to the community. It maybe become a project who is developing the future for data centers. And you know, data center is just a basic component in the infrastructure for the digital society, but it's an important component, and we need to develop it because we're facing great challenges with not only developing the IT environments and the IT services, but we need to save the world in the same time. And the data center facility have a big portion in their scope to create future inventions that could use the energy smart. So reducing the energy for other purposes is going to be in the scope for data center facility. So the idea was optimize the data center, the modular data center for OCP hardware, and it needs to meet the OCP criteria, as we heard, maintainability, cost and energy efficiency, openness and scalability. Always meeting the tenets. Always meeting the tenets, and the project lead in every group is bringing the progress forward to meet the tenets, always checking up. Are we aiming towards the objectives with the tenets, or are we off track? So this is the start. And then you establish the project, and we launched it last year here as a sub-project within the data center facility group. And everybody is welcome to contribute. That's the idea of OCP community. So the community invited the hackers, and now things started to happen. The specialists from the industry, of course, with cooling, power automation, construction, as Brevin told us this morning, this is the content of data center facility. But also, of course, these stakeholders who will have use of these solutions needs to be there and contribute. The telcos, the colocation guys, the hyperscalers, the enterprise users, everybody needs to be in this process. So we address a couple of surveys, I think 2 or something. We address, pinpointed the stakeholders, the telcos, the hyperscalers and the colocation companies within the community. They are there. And we ask them I think decent questions about size, density, effect, and everything, and that becomes the baseline for our design work. Then we kick off with ideas, and we always try to map them, to attach them to the stakeholders' needs So we ended up with a density between 7 and 10 kW per rack. Most of them say we're going to deploy in that area. We have the HPC group as well as a separate group in this community working with high performance compute and high density solutions. We interact with them, of course, and this is for the common market for OCP users with colocation, hyperscales, and telcos. Yeah. So this is one happy family working weekly. We have weekly meetings in this group, and we have continue with that for a year. So every week for a year. And Brevin has done a great work bringing this group forward. So now here we are today. I mean, this is interesting way of working, caring and sharing, and you get the energy from openness as soon as you enter the table and enter these meetings. Because you're together with stakeholders, specialists, engineers and everything, and you drop a question and the innovation starts. It's an iterative progress, and of course, MVP will be minimum viable products. We like to launch, that's our focus. We need to take it to the market, of course. So today, Scott and I will present something that you can buy, of course. The incubation committee has said this is okay, this is the right standards, they're meeting the objectives, the tenets. So this is for sure something that the market could purchase today, and we have published everything on the web page and the wiki. The specs are there, so you can download or read or whatever you like. So it's time to, now we're starting the release party, okay? I'm in time, I hope. So let me present the first, standardizing the MDC specification, the guidelines and specs for modular data center optimized for OCP hardware. And this is to meet the OCP criteria: maintainability, cost and energy efficiency, openness and scalability. And the product info we're going to share with you today, I'm going to present the scalable 300 kW modular data center, and later on Scott Neal will present the standalone version, 90 kW modular data center. So here we go. This is about 1.5 megawatt in this picture. And it's just, you see it's simplicity, infrastructure from the cooling side, from the back, power and fiber connections from the front, easy to deploy, easy to scale out. Preparation of the land, concrete plinths or a concrete foundation, easy to prepare. Time to market is important. You can deploy fast. Time on site will decrease and mitigate the risks as well. That's one of the features when you're working with modular solutions. Well, looking to an IT load between 300 and 500 kW with a density between 10 to 18. You can read the specs if you like more detail to find there. We have also designed with or without UPS system. We have stand with a cooling system to be efficient, a chilled water system with intercoolers. I mean, this is kind of best practice we have started with. Of course, you can use indirect adiabatic cooling or fresh air or what you like, but this design is for chilled water. You get a possibility to reuse the heat as well. If you can connect it to a district heating system or facilities that needs the warm water, you could reduce and have even better PUEs in the numbers and the figures. And we published the weights for fully equipped in factory, or the other way, like the hyperscalers and coolers like to equip the racks fully on the assembly side and roll it in. Yeah. You can see the design is very narrow, hot aisle. Open up the possibility for 2 rack rolls in one module. This is 30 racks in one module. You can see it. You got a possibility to increase the inlet temperature, of course, if you're using only OCP hardware. But we have stayed within the ASHRAE's recommendations in this. When we're presenting the POEs and the numbers, we have used the ASHRAE recommendations. We don't like to scare you people, but you can increase the inlet temperature when you're using OCP hardware. Savings on the operational side, of course, is possible if you use OCP hardware. It's not only the CapEx, you buy them for a less cost, even the operational cost will decrease with a 30% or something like that. Yes, I keep on going. And that's the way it looks. And this is a 2 megawatts or something example, you can see. It's a small footprint with high efficiency when it comes to the construction. Time on site will not be long for that type of scale-out solutions. We can stack it in 3 stories if you like. You can put another floor, 2 other floors up on top if you have not so much land to use when you are deploying your data centers. Yeah, and this table for the summary of the specs. You can see IT load, number of racks, average density, the basic facts for what we have put in this spec. You can read it there in one table, so if you're interested. And we have the partial PUE examples from Europe and from Middle East, just to cover the range of this. And we have been working with an inlet temperature of 20 degrees Celsius. Pretty efficient, yeah. So, planning to deploy OCP hardware. This is a possibility for you to using this design, you are reaching good efficiency on these areas. Energy use will be extremely good, both if you're using the OCP hardware and using the environment optimized for it, you can save a lot of money and save a lot of environmental impact as well. We have numbers for CO2 emissions comparing OCP hardware with traditionals. We publish them as well. I have them if you like to. Of course, you save floor space. This is a good way to have a high density footprint with good efficiency in. IT load flexibility, yes, of course. You can mix in this environment high density or mid density racks if you like, and get a good availability as well. Footprint of the DC I already told you about. You can stack it 3 stories high. If you have expensive land, you can just build it on high. So this was a fast track, and now I will give the word to Scott. Please take over the party. You need this one? Changing the picture?
Yeah, I'll take that.
Thank you.
All right, since I have the microphone, I feel like I am hosting a party.
Yeah.
All right, so I'm going to talk briefly about our standalone solution. You know, the main difference here is it's a bit self-explanatory. It is a standalone, it's a single module versus a scalable design that Roberto discussed. So just getting into the specifications of this, we have a 90K all-in-one. We call it an all-in-one solution that includes the UPS, but you can also get one without a UPS. Obviously, that's another option. You get a bit more capacity. We are limited, in this case, on the 90 kilowatt with an M+1 redundancy on the UPS. You take that out, we can go to at least 100 kilowatts. That's based off the limitation of the cooling system. If we change the cooling system, we could go to even a higher capacity than that. So there is some flexibility in the design. This is a common solution that we tend to sell more often or present to a lot of the customers, so that's why we chose this one as the basis for this particular standard. So in that design, we have 12 racks with a UPS, 14 racks without a UPS. With, you know, if you add more racks, your rack or density per rack is going to go down a bit. So we've got 6.4 kilowatts per rack with UPS, and then 7.5 with UPS, and then drops down to 6.4 without. Again, this is with DX cooling. So with this particular cooling system, this is the density you have. If we need to go up to a higher density, we do have a chill water option. So the DX is using in-row DX coolers, and we'll have condensers on the outside, and I'll show you here a picture in a bit. We'll go through that. The internal space shows some dimensions up here, and I wanted to bring up a topic in terms of a single unit. A lot of times people think of this as a container. I use the term module instead of container because this is not a ISO shipping container. It can be, but typically we don't default to that unless the customer asks for it. So I don't want to steal the thunder. Rob Coyle sitting here in the audience, he's got a presentation at 2 o'clock that'll go into more detail about a module versus container. So if you want to hear more about that, Rob can show you the benefits of that. But the main benefit for in this case is that you're getting a more spacious module, right? More room in the hot and cold aisles. And it is fully shippable just like a shipping container is as well. All right, so we've got some additional dimension or details here as far as loaded weight, empty weight, about 25,000 pounds empty, about 45,000 pounds fully loaded. All right, just looking at the inside, we've got I said a single row of racks, a drop-in solution tends to be a single row rack, so we can do more modules, but then now you get into more of a scalable design that Roberto talked about. So these standalones tend to be just a bit more simplistic. This space can be configured differently. Again, more cooling can be added, less racks if need be, if you need to go to higher density. But in general, this is the typical configuration that we're seeing a lot of customers drive to in that under 100 kilowatt range, right? This could be anywhere from 30 kilowatts up to 100 kilowatts. Typically, you have an entrance area, a lobby. It's kind of hard to see on this end, but the door would be right there on the end of the module. And in that entrance area is basically your electrical room. You're going to have the input electrical panel. You're going to also have a house panel. So this is a building more or less. So you're going to have lighting. You're going to have electrical outlets along the wall. So it's a 120 volt panel as well. You're going to have fire suppression systems, the control panel for that. You're going to have security. Right, so it could be security, it could be monitoring system, but typically all that's stored in that entrance area. And then this is optional, but in this case we're showing where we're closing off the cold aisle and the hot aisle to the lobby, and this is just for preference for a lot of customers where they want an isolated area from the outdoors as you walk into the IT space. You'll see the containment across the top. The containment, depending on the manufacturer, can be done differently, but typically most manufacturers are all putting in some sort of containment system to make this run efficiently. Right? So the configuration of the space could be modified a bit, but in general this is pretty typical. On the outside, we have the condensers on the back side of the module, 4 condensers to match up the 4 in-row units. We've got a couple gen sets. Typically, you're probably seeing 1 gen set. This happened to be a tier 2 design to the letter of the law with the 2, why we show the picture there, but typically it's going to be a single gen set and a transformer on the back side. So that's basically your standalone solution. Other than putting the gen set and the condensers in, you're just dropping the single module in. All right, so why a standalone versus a scalable solution? Right? So a lot of this just depends on the customer set. Your scalable solution is going to tend to be more focused on the larger deployments where growth is necessary in a colo environment, more likely. But you have a lot of customers that are looking more for, I would say, edge deployments. Not always edge, but we'll just use that term because that fits here quite a bit. But it tends to be customers who don't necessarily build data centers as their primary business, right? It's a support mechanism. And therefore, they're looking for the easy button. They're looking for something to drop in very simply. They don't want a lot of complexity. They're trying to simplify their construction site. Their IT guys are not necessarily, building data centers, like I said. So this is what I have up the top here in terms of repeatability, flexibility, and speed. Those are really the primary drivers. Your repeatability makes sense in terms of you have a small solution. You may have a need to repeat this solution in multiple locations. Flexibility really comes in the need of putting a data center where it wasn't really intended. And that's where a modular data center seems to come into play quite a bit more, at least in these smaller form factors. You have factories, warehousing facilities. They're becoming more automated. They need a data center. It wasn't really designed for that. Universities, a lot of times, need to save the space for the classrooms, or hospitals kind of fit in that same category. Telcos, just in general edge deployment. So that's where this solution versus the scalable solution tends to shine. All right. So with that, I think at this point we're ready for any questions, and both Roberto and I are here. Yes, go ahead, Brevin.
Oh. Sorry. There it is.
So what is the timeline for having these products on the marketplace where a customer can purchase them?
Today.
Yeah, we need to do a number of specs to get approval for marketplace, OCP accepted or OCP inspired. But already today you can purchase from us, from Schneider and Swedish Modules, and we have published the designs and the specs already. So the basic design is there, we can produce them, but we're aiming to have them on the marketplace. I don't know the time schedule for that, but we for sure have been ready to configure the CAD drawings, the one-liner diagrams and so on that needed. But you can get in touch with us entering the OCP community, of course. Mm-hmm. We are there, and also if you enter the monthly calls, of course that's a forum for further discussions. But already we can deploy, and I think timeline for starting up the work with specification approved by to enter up at the marketplace will be, I think, during this summer maybe. Yeah, because we are ready to work now. Yeah, please.
So when you buy, do you buy, of course, the external stuff? Do you also buy racks and equipment in it, or that's separate?
Well, we have our factory, and the production there is the steel module and the whole environment, the house. And then we purchase the coolers from Scott or Rob or somebody else. If the scope of works includes the rack, we buy them too and install them. And so, I mean, all the infrastructure is a baseline. I mean, the piping work, the mechanical work, the electrical work, everything should be ready to deploy servers. But many likes to deploy their own servers in their own racks and roll them in. So it's prepared for that situation and case as well. So if you like to have a complete plug and play ready to go, you can get it. We'll lift it and place it at your land. But if you like to deploy the racks and servers by yourself, it's prepared for that as well.
Yeah, I was just going to add to that too. So and we've seen all those scenarios. Customers bring it. We ship the modules without racks, and the customers bring their own in. Typically, we tend to deploy a lot with empty racks, and then we've had situations where they ship them with racks loaded. So we have an integrator come in and do the equipment integration. If you do that, though, you do need to take a strong look at in terms of the benefits of cost, because we have to beef up the module a bit more to carry that load when you're shipping it. So, and then also do some shock proofing on the racks themselves. So there is a cost trade-off that comes with that pre-integration of the equipment versus the strength and the additional cost to do so. But it does happen. We do have customers that do that. Sorry.
Yeah. So to that point, we during the project we did have a discussion. If you look at OCP racks, they're typically pre-configured at an integrator, right, and then shipped to the site fully loaded and going in. We're like, well, what's the chance that we just drop the module off at the integrator, they integrate all the racks there, and then you ship it to the site? And Scott already mentioned some of the challenges there. In addition, some of the integrators aren't really set up. They have all their test rigs and everything inside their facility to test fully configured racks. So to go move that into a module is a little bit difficult. So the modules were definitely designed in mind so that they might be empty. A fully configured rack would show up on site, and it can be rolled into place in the module, kind of like a traditional data center. So good question, because it was a discussion that we had during the project.
Yeah, and you can see in the specs, in the summary, in the table, we have put in the weights fully loaded with racks and servers and without. So you can see the transportation situation for the modules. If you like, we can deploy it fully equipped. And of course, the more readiness from the factory tested and verified there, less risk you have on site. You decrease the time on site, it's a fast assembly on site, risk mitigation is in that scope, but as Scott said, all velocities, we are familiar with every situation, I think, but the best thing is to have an interaction to see the local codes and the demands from the customers. That's the way we work, both companies, when we are deploying and helping you out there. Yes, more questions? Go into the wiki, take a look, yeah?
Do you have any numbers on the cost for this?
A cost for? Yes, we have calculations, different scenarios, of course. We'd like to get help with the KPIs. We can present a cost per megawatt or per rack if you like to, but also that depends on the density, because we have designed modules for 2 megawatts per module, and that decreases the cost per megawatt. But if the traditional here, we have work with 10 kW per rack, we can present some calculations on that typical scenario, if you like. So you're welcome, we can help you with that if you like to take a look at the CapEx and so on. And also for transportation, and later on, I mean, Rob going to present also the benefits of using modules when it comes to transportation costs all over the world. You had it in your presentation, I know that. Yeah,
But,
I promoted a bit here, so
yeah.
2 o'clock if you're interested in these case scenarios. So
just
I will
to
give
add-
it to you, and I think you can give it as well.
Yeah, I
as
was going to give you kind of a
examples, yeah.
rough estimation because there's a big range. If
Yeah.
you get to, like you said, like a 2 megawatt solution, multi-module, very efficient but high density, you could see something as low as $5 a watt. Now that's pretty low.
Yeah. Below
but
that.
that is possible. But it can go up as high as $10 to $12 per watt. If you're looking at a smaller solution, lower density. Again, so and it also depends if you get to these bigger solutions, cost is much more of a driver than say at the smaller level where the customer, it's again about speed. The benefits are not necessarily the direct capital cost. The benefits are that speed, that simplicity, the need to get that thing on site, and the other drivers that why they are looking at it in the first place, why they don't have space for it. So keep that in mind, but in general, yeah, the range, just like with any data center, it depends.
Yeah, but I think it's a good question, and please read the white paper from Schneider, verifying the cost for the external power systems. You really decrease the cost. Your savings are heavy there, 45% or something compared to traditional infrastructure. And also, I mean, if you're using the OCP hardware fully out, for all in with OCP, you're going to save a lot when it comes to operational cost. And also the CapEx will go down. Mm. Please interact with us. Go to the wiki. We have all the specs there. Yeah, you have.
Before you close,
yeah. Yeah, absolutely.
Okay. So one thing I want to point out that the output of this project was not just these 2 specifications for the 90 kW and the 3 kW 300. And I've said this on a bunch of calls, so those are on the call notes. It's the actual format of the specification. So if you, right here, we have PCX, we have Swedish Modules, we've got Schneider. If we were to kind of just go out on the market and show a specification, I bet all 3 of them would be different. If, of the 20 people in here who might request a prefabricated module, the way you request that could be probably 20 different ways. So having just a standard format of how you organize your information could be massive for the industry. So now comparisons are easier, the conversation between the customer and the vendor is much easier because the information's there. So I think that's a major, major output of this project, which should continue to be developed because it's reasonably basic right now, but it can be developed further to make, again, the whole marketplace more efficient that way. So just want to I say that every time, but
So, yeah, and if we close this session, I will say if you go into the web page and contributors, we are there, so you can read, you can download, and on the wiki we have all the material published there as well. Some pictures and some drawings, and in the specs you have some drawings and schedules, schematics of electrical infrastructure, cooling infrastructure, and a lot of text information as well, and some pictures, drawings. Yeah, we're done. If you don't have any further questions, we're here to interact with you this day, and of course, anytime. Yeah.
So I'm a Japanese data center provider, and there are many earthquakes in Japan. So
Yeah.
is it possible to install the earthquake resistant system underneath of the module data center? Earthquake resistant system.
So yeah, again, it does depend on region. So you asked about the earthquake or seismic.
Well,
seismic
seismic,
bracing.
yeah.
So yeah, we've deployed those where we have like a spring system underneath the modules. You can also do it at the rack level as well. So again, it does depend a bit on region where you are, but yeah, we have those systems available.
And also, I mean, we adopt the sizes because when we deliver to Japan, we know the roads are a little bit narrow, the bridges are a little bit lower, so we adopt the sizes to fit your purpose. And yeah, that was answer your question, okay? Good. Are we in time, Mr. Buncher?
very well.
Very well, yeah.
Very much so.
Yeah, very much, okay. So we still have time for questions before we go to the keynotes, or shall we close the party?
All right, thank
okay.
you.
Thank you for listening.